in the area. There we go. We're going. Okay, welcome to Noise Engineering Podcast, episode number 16. We're going to be discussing acoustical absorption and its many applications and different types of acoustical absorption. But first, I'd like to present the newest member of the Sound Solutions team, Kemper Brightman. And he is going to be responsible for acoustical noise measurements, analysis, and report generation for architectural acoustics and environmental acoustics projects. That'll include mechanical noise and room acoustics, which is what we're talking about today. So we get a lot of projects, a lot of requests for acoustical absorption. This is one of the key areas we address. That includes factories, gyms, community centers, call centers, theaters, churches, shooting ranges, Legoland or malls, libraries. And the goal with applying acoustical absorption is to control the reflections, control the reverberation time in a space. It can reduce the noise level and make speech intelligibility better, make it easier to understand the spoken word. There's many types of acoustical absorptions. The base materials that are absorbing tend to be fiberglass, foam, cotton bats, mineral wool, acoustic ceiling tiles, and spray-on foam, but not any spray-on popcorn ceiling foam. It's got to be an acoustically absorptive open cell foam. And then there's many different ways to cover the acoustic materials, and that could be for aesthetics or for durability. You can put fabric wrapping around them. They have to be fire retardant, fire wrapping. You can use perforated metal, perforated vinyl or PVC, wood, open slats, or just a cloth, some kind of a thin cloth sometimes will go, or some treatment right to like fiberglass. The covering, usually the performance of the acoustical absorption will depend on the density of the absorptive material and the thickness. And the thickness really controls how well it performs at lower frequencies. The thicker the material, the better it'll perform at lower frequencies. And density usually increases the acoustical absorption.
So there's a lot of applications here, and there's a lot of different types of materials that you can use. And I think it's important to recognize that you don't have to lose the aesthetic value of a space just to make the noise quality better or to dampen those levels a little bit. You can use wood, you can use all sorts of different coverings that will either blend in or even stand out and add some aesthetic value, just depending on your application.
Yeah, I think that's important. Durability, the aesthetics, and cost usually drive the selection. We usually are doing some modeling to determine how much absorption should be used and where it should be applied. One of the key indicators of how much acoustical absorption should be applied is reverberation time, and that's the amount of time it takes noise in a space to reduce 60 decibels. We can model that based on the volume and the surface treatments that exist, also the number of people, furnishings, wall or floor coverings. Or we can measure it. We go into a space with a loudspeaker, blast broadband noise, and turn it off. And the amount of time it takes in each frequency, in each octave band, to reduce 60 decibels would be the reverberation time in each octave band. And you can, with a model, add absorption and determine how much noise reduction will be achieved with certain treatments, or what that final reverberation time will be with different treatments. And we compare that against what the desired reverberation time is to make recommendations. generally for noise reduction, we want to treat the ceiling and at noise source height. The acoustical absorption on the walls at noise source height will reduce flutter echoes, will reduce the noise levels from that source. Anything above noise source height will hit the ceiling. So treating the ceiling a lot of times is a common way to attenuate the buildup of noise in the space.
I think there's sort of different things that work for different spaces, but in general, the ceiling is an area that is not incredibly visual, and it's also much easier to treat that than putting things directly on the floor. You wouldn't want to be working on fiberglass panels, but it's much easier to hang them up on the ceiling.
And even on the walls, they can be more prone to damage.
Mm-hmm.
And the costs of treatments can be pretty reasonable. I'm getting some feedback. The treatments can cost less than $1 a square foot, but depending on what kind of covering you want, where the project's located, and how complicated the installation is, the prices can go up above $10 a square foot, just depending on installation, transportation costs, in addition to the material selection and covering.
Would you say that it's easier to, or maybe more inexpensive if you treat the space before it's built, or come up with some ideas of how the acoustics are going to be before it's built versus having to mitigate risks after you've already built the space?
Great point. It is definitely, we love dealing with projects at design and development phase instead of after there's installations. Spraying on treatments, it's much easier to do when there aren't already furnishings and carpeting in there or equipment in a space. Wall panels, I mean, these can be part of the design, part of the art, part of the aesthetics in the design phase. So it's definitely less expensive and easier to consider those issues when you're designing the space. Good point. I think that wraps up what we want to cover in episode number 16. Please check out our channel for other podcasts and videos. You can find out more at noiseengineers.com. We appreciate any feedback you have. We recommend, or we welcome suggestions, comments, questions. Feel free to get in touch with us. And thanks for watching.
Thanks.